Hello friends, you're welcome. It's Dr. Cliff. Today we are going to be looking at redox versus non-redox reaction. What are redox reaction and what are non-redox reaction? Alright, now you must be knowing that on the basis of transfer of electrons, there are two types of chemical reactions. There are two types of reactions on the basis of what transfer of electrons. Alright, now they are what? The redox reaction and what? Non-redox reaction. Now, what is redox reaction? A redox reaction is one in which there is what? Transfer of electrons or change in oxidation number. So, what does that mean? When you see a particular redox reaction, there is going to be transfer of electrons and there's also going to be a change in oxidation number. So, the transfer of electrons consequently lead to what? A change in oxidation number. So, when you talk about redox reaction, the term redox was taken from redox. Now, the word red, and us, there are two words. Now, red is indicative of what? Reduction. Us is indicative of oxidation. Okay, so that's why you can call it reduction oxidation reaction. So when we are talking about redox reaction involves reduction and oxidation reaction. So if you see a particular redox reaction, there is going to be reduction and there's going to be oxidation taking place concurrently, taking place simultaneously. So this reduction and oxidation, they are two opposite but complementary processes. All right, so we are going to take a look at that now. Let's see. So I have sodium plus chlorine, sodium reacting with chlorine to give us sodium chloride. Okay, equation balanced, right? Okay, now the oxidation number of sodium here is 0. Oxidation number of chlorine is 0. Why is this 0? Element in the free state have oxidation number of 0. If you come here, sodium is going to be what? +1, and here chlorine is going to be what? -1. Okay, you can see here they are now in combined state. All right, they are now in combined state. Now you will say that from here, from let me take this, from here to here, from sodium, trace the sodium from this sodium to this sodium. What do you see? You're going to see something. Now trace this chlorine from this chlorine. Now what do you see? This is from 0 to +1. That's an increase. Increase in oxidation what? Number. Increase in what? Increase in oxidation number. And increase in oxidation number is called what? Oxidation. Okay, that is one of the definition of oxidation. So if you take a look at chlorine from 0 to -1. So on the reactant side, chlorine is what? 0. On the product side, chlorine is what? -1. So from 0 to -1 is what? Reduction. So that's what? Decrease in oxidation number. So that's reduction. So that's one of the definition of what? Reduction. Please watch up my video on reduction and oxidation for better understanding. All right. So having known this, now you can see that sodium is the one that is undergoing oxidation, while chlorine is the one that is undergoing what? Reduction. You can see that reduction and oxidation are taking place concurrently, simultaneously, at the same time. So that is what we're talking about regarding what? Redox reaction. So before that, I need you to know something. Now, let's talk about it on the basis of transfer of electrons. Okay, on the basis of transfer of electrons, what does it mean? It means that sodium, take a look at something. I need you to have a picture of this. If sodium, this is sodium is highly electropositive and chlorine is electronegative. So sodium is going to lose one of its electron, okay, and when it loses that, it becomes Na+. It becomes sodium ion. All right, like this. Now chlorine is going to gain an electron. So chlorine is going to now become like this. Okay, so this is sodium ion, and this is chloride ion. So this, for sodium to become like this, it has to lose its electron. So who is transferring electron? Sodium is the one transferring an electron. Chlorine is the one gaining an electron. So they will now become NaCl. So that is how this whole thing is formed. All right. So sodium will lose its electron to become sodium ion. Chlorine will gain an electron to become what? Chloride ion, to form what? When they combine together, they're going to form this. All right, so that's basically what happens. Now you can see that there's a transfer of electrons. Sodium is the one transferring the electron. All right, and who is gaining the electron? Chlorine is the one gaining the electron. Okay, now you can see that's why we talk about redox. That in redox reaction, there is transfer of what? Electrons. Sodium is the one transferring the electrons here. And because there is transfer of electrons, it consequently leads to what? Change in oxidation number. So that's the reason why over here sodium was 0, and over here sodium is what? +1. Because when sodium was like this, let me bring it out here. When sodium is like this, when it loses an electron, it becomes what? Na plus E minus. This is the electron it loses. So here sodium have oxidation number of what? Sodium have oxidation number of 0. While here sodium has oxidation number of what? +1. Okay, +1. Okay, you can see that from 0 to +1, what will you call that? From 0 to +1, that is what? Oxidation. So you can see that sodium undergoes oxidation. So oxidation is simply what? Increase in oxidation number. From 0 to +1 is an increase in oxidation what? Number. Therefore chlorine, when chlorine gains an electron, it becomes what? Cl minus. And chlorine here is 0, and chlorine here is what? -1. So from 0 to -1 is what? Reduction. Okay, so you understand that now, isn't it? Good. Sodium is the what? Sodium is the reducing what? Agent. Chlorine is the oxidizing what? Agent. Okay, now why? It's simple. Don't worry, I'm going to teach you. Now it's tricky, but you just need to understand. Now you are going to change the initial. You're just going to change it. Okay, us and red. Now reducing agent, you are just going to change it. Instead of saying oxidizing agent for sodium, sodium is the one that undergoes oxidation. The agent that undergoes oxidation are called the reducing agent. Okay, are called the reducing agent. Now you simply, how do you easily remember? How I remember is simple. I will just simply say, what process does sodium undergo? The species that undergo whatever change the name. Now sodium undergoes oxidation. Oxidation. So it's going to now be the what? The reducing agent. Okay. Why the agent that undergoes reduction is going to be called the oxidizing what? Agent. You can see we just simply changing the what? The letters. Okay, the name. Now, reducing agent is also called what? Reductant. Okay, reductant. Oxidizing agent is also called what? Oxidant. So which means I can call sodium reductant, I can call chlorine what? Oxidant. So you will be asked in your exam, which of the following is the what? Reducing agent, which of the following is the oxidizing agent? One thing you must know is that reducing and oxidizing agent are usually present on the reactant side. They are never present on the product side. That is a very important information you must have. Okay, reducing and oxidizing agent are always what? On the reactant side. Okay, so reductant, oxidant, they are the synonyms for reducing and oxidizing agents, okay, respectively. Now you can see that, having told you all this, you can see that redox reaction is an interaction between reducing and oxidizing agent. Right? It's an interaction between what? Reducing and oxidizing agent. Sodium is the reducing agent. Chlorine is the oxidizing agent. So it's an interaction between the reducing and the oxidizing what? Agent. All right. So you can see that redox reaction involves two opposite but complementary what? Processes. So reduction and oxidation, opposite but complementary, isn't it? So that is redox reaction. Okay. I will give you another one. let's say hydrogen plus oxygen giving us what? 2H2O. So this is hydrogen here is going to be what? 0 element in the free state. So you know when hydrogen combines with water, it's going to give us what? When hydrogen combines with oxygen, it's going to give us water, right? So hydrogen in the free state is 0, oxygen in the free state, element in the free state is 0. So here hydrogen is +1. Come on, hydrogen is always +1 except in hydride, metallic hydride. So oxygen is always -2 except in peroxide where it is -1 and in superoxide where it is -1/2. So you can see that from here, from this hydrogen, let's trace the hydrogen. From 0 to +1 is what? Oxidation. That's an increase in oxidation number. And from 0 to -2 is what? Is reduction. Okay, so who is the reducing agent here? The reducing agent is what? The reducing agent is what? Hydrogen. Why? Because it's the one that undergoes what? Oxidation. So reducing agent is what? Hydrogen is the what? Reducing agent. Oxygen is the what? Oxidizing what? Agent. Okay, that's that. Now let's talk about non-redox reaction. So we are just going to change some simple stuff. So instead of saying redox, we are going to put non-redox. Non-redox. So here they'll put no. So in a non-redox reaction is one in which there is no transfer of electrons, consequently leading to what? No change in oxidation what? Number. Okay. All right. Now let's take a look. If examples of non-redox reaction. Examples of non-redox reactions are number one is double decomposition reaction. And number two, double decomposition reaction is also called double replacement reaction, and its double replacement reaction is also called metastasis. So whether you call it double decomposition or metastasis or double replacement reaction, all of them mean the same thing. So it's an example of what? Non-redox reaction. Number two, neutralization. And number three, hydrolysis. So whenever you see these headings, they are examples of what? Non-redox reaction. Now, a good example of non-redox reaction for hydrolysis of what? Ammonium chloride. Hydrolysis of compounds like ammonium chloride. That will give us ammonium hydroxide and what? HCl. So if you take a look, there is no element in the free state. Now, let me just simply give you a clue how you recognize a non-redox reaction. Non-redox reaction, they don't usually have any element in the free state. Okay, they don't usually have any element in the free state. Do you see any elements in the free state here? No. So that tells you it's a non-redox reaction. That's a sharp and intelligent way to recognize a non-redox reaction. Okay, that's an intelligent way to recognize a non-redox reaction. So for neutralization reaction between hydrochloric acid and sodium hydroxide to give us what? Sodium chloride plus water. So you discover that this is also, you will see that all of them, there's no any element in the free state. So here hydrogen is +1, -1, chlorine is -1, +1, oxygen is -2, hydrogen is +1, sodium is +1, chlorine is -1, hydrogen is +1, oxygen is -2. So you can see that all the atoms here, they have the same oxidation number. Hydrogen is +1 here, hydrogen is also +1 here. So there's no change in oxidation number. Chlorine here is -1, chlorine here is also -1, no change. Sodium here is +1, sodium here is +1. You can see there's no change in oxidation number here. So that's why there is no change on this, or there is no change in oxidation number simply because there is no transfer of electrons. Because there is no transfer of electrons, so there is not going to be any change in oxidation number. So for double decomposition reaction, a good example of double decomposition reaction is when silver nitrate, I think you remember sodium chloride. When sodium chloride, let me do that with this. When sodium chloride reacts with silver nitrate, that will give us silver chloride plus sodium nitrate. Okay, this is an example of double decomposition reaction, very common, right? Okay, now you will see that there's no element in the free state, isn't it? So that is how you recognize non-redox reaction. There is usually no element in the free state. Okay, there is usually no element in the free state. All right, so we have come to the end of this session. It's Dr. Cliff. Bye for now.